So, welcome to Unit 4. Yes, the fun meter is pegged now. Okay, we're going to be doing unit circles, degrees, radians, angle measurements, trig functions, and it'll just be serious fun, I know. Anyway, we're going to start with how do we measure angles, some of which you're familiar with, some of which you might not be familiar with, but you will be by the time we're done. So here we go. Alright. You're going to be able to demonstrate understanding of angle measurement by defining DMS, aka degree, minute, seconds, and radians. So let's start with DMS. Make the connection. D M S. Okay, degree, minute, seconds. Get the connection. Degrees, base 60. FYI, free of charge here today. The 360 degrees in one turn. There is a theory out there that at one time the Earth went around the Sun once every 360 days, thus the 360 degrees in one turn. I can't attest to the truth value of that, as can no one else, but it is interesting. More importantly is the definition. So we're defining this 1/180th of a straight line. So we got the straight line thing regardless of how many around in a circle. 180th of a straight line. So you got 360 in a full circle, and we'll get into the details of that here shortly. All right, if we use time, the DMS deal, if we divide that up, essentially it's degrees, minutes, seconds, and we need to be able to convert from DMS to radians, from radians to DMS, degrees, so on and so forth. So let's take a look at a couple of examples. First of all, symbols, and I can't type these, so you have to put up with my handwriting. Okay, let me change the width of the pen here. Alright, so symbols. Degree, you're probably already familiar with. That's the little circle, so freezing, 32 degrees Fahrenheit. Okay, so that's the symbol for degree, is a little circle. Minute, and there are 60 minutes in each degree, just like there are 60 minutes in an hour. And the minute symbol is 1 dash, so you could have, for example, 32, let's say 32.425 degrees, and we can change that to degrees and minutes by doing this. We can say, okay, well, we're going to have the 32 degrees plus the 0.425 degrees, but every 1 degree has 60 minutes, and so it actually converts. Then our degree goes away, this symbol goes away, leaving us with this symbol. And so we're looking at, say that would be 32 degrees and 25.5 minutes. Which is all well and good, but we're not done yet. In fact, we'll go one more. Let's go ahead to the next slide. And the next slide says, okay, we've still got our 32 degrees and our 25.5 minutes, but now we're going to go seconds, and our seconds, the symbol is a double hash mark, if you will, and so we're looking at 32 degrees and 25 minutes plus 0.5 minutes times 60 seconds in each 1 minute. And so again, this little guy here goes away, and we are left with 30, half of 60, right? 30. So our final would be, say, 32 degrees, 25 minutes, and 30 seconds. All right. Now if we switch gears and go the other way, there's a little bit of a curveball you got to watch out for. If you're going from DMS to degrees. So let's say, for example, we've got 42 degrees, 24 minutes, and 30, sorry, go backwards. Can I do that? No, it won't let me. So I'm just going to write over the top of it. 36 minutes. So that's 42 degrees plus we've got 24 minutes, but remember there are 60 minutes in a degree. And then here's where the curveball comes in. We've got 36 seconds, but there's not 60 seconds in a degree. There are 60 times 60. So this is the part to be careful of. So you got 36 over 3600, which of course you can all do in your head to come out to 42.41 degrees. I'm kidding about doing it in your head, by the way. So we have now gone from degrees to degrees, minutes, and seconds, and from degrees, minutes, and seconds back to degrees. So that would be, man, we're already, well, we're a third of the way through this first section. Good all over us. Alright, we need to talk about navigation. And navigation is sometimes confused with the unit circle, and I want to try to eliminate some of that confusion. Navigation, we have defined, we've got cardinal, what are called cardinal, as in the major points of the compass. So we've got north, east, south, and west. And what we've done is we've come in and we have defined north as being 0 degrees. Now that's not the same as a unit circle, so I'm going to caution you right now, do not confuse the two. Okay, this is not the unit circle. North is 0 in navigation. East is 90 degrees, south is 180, and west is 270. So we've just simply defined it that way. So if we put this on a coordinate system, okay, let's just say, for example, me get a grid here. So I'll change colors. Alright, we're going to have a grid, and you'll have to pretend those are exactly 90 degrees from each other. 0 is north. So if we have, let's say we're headed off and we're going on a vector of that direction, and we measure from 0 degrees and we say, okay, this is, oh, and it looks like somewhere around 57 degrees to me. I don't know what it is exactly, but we'll say it's 57. So if we do that, then this has a heading of 57. So we say it's heading at 57 degrees. If we were heading, let's see, someplace, well, let's introduce another concept. Let's say that we're heading like this, and we know this is 45. All right, so we're not going straight east. Okay, we're not going east, and we're not going south, but we are going halfway between, so we are going south east. So it's halfway to south from going east, would be another way to think about it. It's also a heading of, if you want to just do the heading, it's a heading of 90 plus 45, which is 135. And to make sure that we are thoroughly confused, let me change color again. Let's come in here, and we're going to go this way, and we're going to say this is 22.5, which would be half of 45. So we're halfway again between halfway of going west and south. So we would say this is west, south, west. So again, we're not going west. We're not doing this. Okay? We're not doing that. We're not doing south either. But we're not doing southwest. This would be southwest if this were 45 degrees right here. So this is southwest. We're doing halfway between that. So we are doing west, southwest. That's this guy right here. Now, if I haven't confused you completely and totally, thoroughly at this point in time, stay tuned, because I will have another chance at it. So, here we are. We've done DMS, we've done a little navigation. Now we're going to do radians. Okay, right here. Okay, radian. We're going to define that. Now, I'm just going to be pointing some things out here, so see if you can follow along. We've got this circle. Now, this is the unit circle. Notice, okay, 0 is over here on the right hand side. We call it a unit circle because R is equal to 1. Whatever unit we have. It could be 1 meter, it could be 1 inch, it could be 1 everything. Anything. It's 1. So it's a unit. So we have the point 1, 0. That's point A right here. Okay, let's stick an arrow on it. Point A right here. Oh, there it is. Look at that. Okay, so that's point A. It's the point 1, 0. So we're over 1 and we're up 0. Now, a radian is defined comparing how far around the circle we go So if we start at 0, 0, and we go around the circle this way, okay? If that arc length, delta S, is equal to the radius, however big that is, then we say, by definition, that is 1 radian, and we give it the symbol theta. We are measuring this angle. So this line drawn from the center of the circle to the point 1, 0, if we take that line and let it sweep across this and make this pi shape, we are saying that that is 1 radian by definition. Over here on the right hand side, right there's point B, and that's the same as that point B in length. We've gone around the circle from point A to B, so we've gone from here to here, and that's the same length as going here. Notice also we orientate it so that it is a positive value. So when we go around the circle counterclockwise, it is positive. When we go around clockwise, it is negative. We are going down. By definition, down is negative. So, radian defined right here. In fact, let's do this. Make sure you see it. Right here. That's what we're after. We're going to refer to that time and time and time again. Please tattoo that on your eyelid somewhere. Okay, that's where we start with radians, and we are a long way done. A long way from done. Thank you very much. Okay, so we're going to continue our discussion here. You can see I've got a little graph showing up here. And this is a graph of circumference as a function of diameter. And when you do that and you find the slope of that, which is circumference divided by diameter, we get this thing called 3.14. And some of you might recognize, I hope all of you recognize, that that is actually indeed, yes, it is pi. Now, make my pen a little skinnier there. Pi, that's not just pi, that's pi. Okay, I'll stop. Here's my point. Circumference, then, is pi times diameter. And we know that diameter is 2 times the radius. So using both of those pieces of information, we can say that circumference is pi times 2 times the radius, which you would recognize if we rearrange it to the all too familiar circumference is equal to 2 pi r. Now that's all very good and interesting. So how are we going to use that? Well, stay tuned. Here we go. Since circumference is 2 pi r, and a radian is how far around the circle have you gone compared to its radius, and how far around the circle is the circumference. Therefore, and yea, verily, I saith unto you, that 2 pi r over r is 1 circle. So there are 2 pi radians in 1 circle. Now, what that allows us to do then, of course, is to convert. So we've got 360 degrees is 1 time around, so is 2 pi radians. And so we can manipulate that, and we can say, okay, 180 degrees is pi radians, so on and so forth. So it leaves us with lots of opportunity to go back and forth between degrees and radians. Radians is the key. Okay, radians is what we like. Stay tuned. Okay, do not let the terminology hide the concept. If we say circumference, if we say revolution, okay, remember revolution is going around an object. So essentially you are going in a circle. Revolution is going around. Rotation is spinning. Some of you saw my very, very talented demonstration of the difference, and my contention that you can rotate without revolving, but you cannot revolve without rotating. And if you don't understand that, that gives you fodder for class discussion. I can show you the difference. Don't let the terminology hide the concept. We're going around a circle. Circumference, revolution, rotation, 1 turn, a circle, a period. Oh, how interesting. This is the time for 1 circle. Go 1 time around. That's the period. Okay, cycle. These are all terms that describe the same concept, and they can all be described as either 2 pi or some multiple of such. All of these, 2 pi. And come to class tomorrow ready to work out of your book and to explore this a little bit more. Which brings us to Yippee Yahoo.